Hey guys, today we're going to talk about the quotient rule. So you've done power rule, we've done product rule, now we're going to throw into the mix the quotient rule. So if you're given a function where you are dividing two things, so remember that's what quotient means, you're dividing. U is going to represent your numerator, whatever expression you may have up there, and V is going to represent the expression that's in your denominator. So if you take a look, here is your formula that you're going to use. Okay, u prime v minus v prime u all over v squared. Now, the first thing I want you to do is I want you to make sure that you keep track of what is u, what is v, what is u prime, what is v prime, just like we did with the product rule. So I'm going to first start off by identifying each one of those. So u is x minus 1, that's the numerator. V is 2x plus 3, that's the denominator. Now I'm going to go and find u prime. So if I'm going to take the derivative of x minus 1 using my power rule, I'm just going to end up with 1. And using my power rule, I'm going to take the derivative of 2x plus 3, and that's just going to give me 2. All right, so now I'm going to set up my derivative. Remember the dy over dx, that just means the derivative of y with respect to x. It's just the same thing as if I wrote y prime or if I wrote f prime of x. Those are all different ways to note that it is the derivative. Okay, so I'm going to fill in using my formula. So we have u prime, which is 1, times v, which was 2x plus 3, minus v prime, so that's 2, and then times u, which is x minus 1. And we're going to put all of that over v squared, so the quantity 2x plus 3 squared. And now you're just going to simplify. So we have dy dx equals 2x plus 3. I'm going to distribute that negative 2. So negative 2x plus 2 all over the quantity 2x plus 3 squared. Okay, so we have dy dx. We're going to go ahead and combine some like terms now. So if you'll notice, the x's cancel in this case. So negative 2x and positive 2x. And then you have 3 plus 2, so that's going to give you 5 over the quantity 2x plus 3 squared. So that's your derivative of your function using the quotient rule. Okay, so you're going to try number 2 on your own. You're going to identify u and v and u prime and v prime, substitute them into your formula, and simplify. Okay, so go ahead and pause the video, do number 2, and then replay the video when you're ready. Okay, how'd you do? Did you end up with negative 22 over the quantity 5x minus 2 squared? Okay. All right, so that's your derivative using your quotient rule. So now we're going to bring back some of the stuff that we've already talked about. We've already talked about writing the equation of a tangent line to a given function. Okay, so if you take a look at number 3, it says find the equation of the tangent line to the graph of y equals 2x squared minus 4x plus 3 over 2 minus 3x when x is equal to 1. So in order to write the equation of the tangent line, there's a couple things that you need. You need the slope and you need a point that is on the line. Now remember, a tangent line shares a point with your curve. So whatever point's on the curve at that point, you're also going to have your tangent line there. And in order to find the slope of the tangent line, you find the derivative. So in this case, we're going to use our quotient rule in order to find the derivative so we can then find the slope when x is equal to 1. So we're going to start off identifying u and v and u prime and v prime. So u is your numerator, 2x squared minus 4x plus 3. And v is your denominator, 2 minus 3x. Okay, now u prime, use your power rule. 4x minus 4. V prime, using your power rule, negative 3. So now what we're going to do is we're going to use our quotient rule to find our derivative. So we have u prime v. Make sure you keep your correct notation as you go here. I don't care if you write y prime or you write dy dx. Just make sure that you're using the correct notation. So we have the quantity 4x minus 4 times 2 minus 3x minus, and then we're going to put in v prime, so we're going to do a negative 3 there, times 2x squared minus 4x plus 3. And then we have that, all of that is over v squared, so 2 minus 3x squared. Okay, I want you to carefully simplify this, so that means you're going to do a little distributing in your numerator there. Be careful when you distribute this negative 3, okay, because you're really subtracting all of that. So you can do that in 2 steps if you wanted to. Whoops, hang on a second. Okay, back to normal. You can distribute the negative 3 here first if you wanted to. So you could say that this would be negative 6x squared plus 12x minus 9. So that would be if you just distributed the negative 3 to that quantity. Now you're subtracting all of that. Okay, so now you want to go back through and make sure you distribute that. So I just want to make sure that you're being careful on those little algebra things. You're going to double distribute here. So we got 8x minus 12x squared minus 8 plus 12x. Now we're going to distribute that negative. So this is going to become a positive 6x squared minus 12x plus 9 all over the quantity 2 minus 3x squared. So really in these, it's not that it's difficult, it's that you really need to pay attention to your algebra skills. You know, the multiplying, the distributing, the negatives, those are the things that you really got to watch. All right, now we're going to go back and combine some like terms. So it looks like we have a negative 6x squared. So that takes care of those 2 terms. And then let's see, let's go and take a look at our x's now. So we have a oh, look at that. We have a positive 12x and a negative 12x. So we can cancel those, and that's just going to leave us with a 8x here. Okay, and then we have a negative 8 and a positive 9. So that's going to leave us with plus 1. All over the quantity 2 minus 3x squared. Okay, now there's the derivative. This is the formula for your slope of your tangent line. Now we want to know what's the slope when x is 1. So we're now going to do the derivative. You're going to take that formula that you just found for your derivative and you're going to substitute in 1 for x. So you're going to take the derivative and you're going to evaluate when x is 1. So negative 6 times 1 squared, 8 times 1 plus 1. Quantity 2 minus 3 times 1 squared. Okay. So let's see what this gets us. So we get negative 6 plus 8 plus 1 all over, let's see, that's going to be 2 minus 3, so it's going to be a negative 1 squared. What happens when you square a negative? Yeah, right, becomes positive. Okay, and so that's just going to be 1 on the bottom. So we're going to have negative 6 plus 8, so it's going to give us 2, plus 1 more is going to give us 3. Okay, now that gives us our slope. Okay, so this is the slope of our tangent line. We still need a point though. Remember that your curve and your tangent line share the point. So when x is 1, we want to actually evaluate using the original up here because we want to find that point on the curve. So you're going to do y of 1. You're going to substitute 1 back into the original. Okay, so now when we simplify that, we end up with 2 minus 4. So that's going to give you a negative 2 plus 3 is going to give you 1. And then 2 minus 3 is negative 1. So that's going to give you a negative 1. So that means the point 1, negative 1 is on the curve. And it also is on the tangent line because remember they share that same point. So now you're going to write the equation of your line. So who remembers the formula, point slope formula? Y minus y1 equals m times x minus x1. Okay, and then you're going to use your point here. So this is going to become y plus 1 equals 3 times x minus 1. And that's your answer. Okay, all right, number 4 is the same type of question. So you're going to use number 3 as an example. So go ahead and pause your video, do number 4, and then when you're ready, you can replay your video and I will have the answer up there for you. Okay, how'd you do? We have y plus 4/5 equals 8/25 times x minus 0. You could have written something equivalent to that. You can write it in y equals mx plus b form if you really want to. You don't have to. I suggest just putting it into your point slope and then being done with it. Okay. All right, number 5 is a little bit different here. So one of the things that you can do when you're using these rules is you can always simplify an expression before you use one of your rules. So in this case, we have a complex fraction. So this is over 1, 3 is over 1. So what I'm going to do first is I'm just going to get rid of this complex fraction. So my common denominator here is x. So this gets an x, and then all of this gets an x. So this is going to turn into y equals, and I can ditch my denominators here. So we have 3x minus 1 over x times x plus 5. Or if you wanted to say that that's the same thing as 3x minus 1 over x squared plus 5x. Okay, now that I have it set up like that, now I'm going to go ahead and use my quotient rule. So if you have a complex fraction, like you do in number 6, I would suggest getting rid of the complex fraction first before you use your quotient rule. So in this case, u is 3x minus 1, u prime is 3. V is x squared plus 5x, v prime is 2x plus 5. Now you can go ahead and find your derivative using your quotient rule. Okay, so you're going to do 3 times x squared plus 5x minus, going to have to do a little double distributing here. Okay, and then that's all over v squared. Okay, and just be careful using your algebra skills here. Careful multiplying, be careful combining like terms. Here, if you want to distribute this first, so this ends up being 6x squared minus 2x plus 15x minus 5. That would then in turn, that would turn into 13x. Now you're going to subtract all of that, so you want to be careful. That's something that you guys really got to watch. So it's negative 6x squared. And then we have a minus 13x and plus 5 all over our quantity squared. So let's go ahead and combine some like terms now. So we have a negative 3x squared, and then it looks like we have 2x plus 5 all over x squared plus 5x squared. And there's your derivative, so you can leave it just like that. Okay, so this time you're going to pause your video and you're going to do number 6. And what I want you to do first is I want you to go ahead and get rid of that complex fraction before you use your quotient rule. Okay, how'd we do on number 6? Hopefully you did a good job getting rid of that complex fraction there. Okay. All right. Now the next two, actually the next 3 questions, I'm going to skip 7 and 8. We'll talk about those when I get back, okay? It's a combination of using your product rule first and then using your quotient rule. So we're going to skip 7 and 8 for now, and then when I get back, we'll talk about those. And then number 9, if you move through that, I want you to do that question with your group. Okay, so after you're getting done watching the video and you guys get back together in your groups, go ahead and take a look at number 9. So this is a word problem where you have to use the quotient rule in order to answer the question. So you're going to answer that question. There's a little chart for you to fill in, do a little analyzing of some data. Okay, and I will see you guys next class. All right, thanks. Have a good rest of your day.